Hi, welcome to my channel, JaberTime. Today we're going to go over solving linear equations in one variable and solving a rational equation. We're going to talk about inconsistent equations, conditional equation, identity equation, and solution set. Solve linear equations in one variable. So when you solve equations in one variable, we are dealing with pretty much this type of equations where a does not equal to 0 because we don't want to cancel the x variable. A linear equation is an equation of a straight line written in one variable, which is, as you can see right here. Okay? Ax plus b or mx plus b and so on. Now, an identity equation is true for all values of the variable. Here's an example of identity equation. Why this is called identity? Because if you try to solve it, simplifying on the right side, you get 2x plus x, which is 3x. The solution set consists of all values that make the equation true. For this equation, the solution set is all real numbers because, to try to solve 3x equals 3x, you're saying the same amounts. It's almost like you're saying what values will fit an equation that says x equals x. Any number will do. That's called identity. It works all the time for any number. Next, a conditional equation is an equation that has an answer that fits some values. For example, 5x plus 2 equals 3x minus 6. We have the following to try to solve it. So if you subtract 3x from both sides, I get 2x on this. And subtract 2 from both sides, I get minus 8. Divide by 2, you get only one answer, which is x equals -4. That is called conditional equation. Next, the solution set is just one number, which is -4. It is the only solution, and therefore we have solved what's called a conditional equation. An inconsistent equation results in a false statement, which means 5x minus 15 equals 5 times x minus 4. That's not true. We have the following to verify. Try to solve it. Subtract 5x from both sides. Add 15 to both sides, or cancel the 5x, by the way. When you subtract 15 from both sides, you could just see that the 5x cancels. So what you have on the left is -15. When you have on the right is -20. And that's not true. That's a false statement. That's called inconsistent. So inconsistent means no solution because it doesn't work. All right? There is no solution because this is an inconsistent equation that has no solution. It's like you're solving two equations for two straight lines, but the straight lines do not intersect. They are parallel lines. That's called inconsistent. There is no point of intersection. Solve an equation in one variable. To do this, if you take your time, we're gonna refer to the linear equation, and we're gonna subtract 7 from both sides, as they say. Divide both sides by 2, you get one answer, which is x equals 2. The solution is 6. Another one, when you have variables on both sides, as you could see, we try to do our best with our skills, distributive property, combine like terms, and moving on. Let's say apply standard algebra properties. Here we do the distributive, As you can see, we do the distributive again right here. So it's like 2 steps in one. Minus 12 and minus 12 cancels, combine like terms, and minus 12 cancels. I got 15 minus 30, which is minus 15. Divide, or let's say add 5x to this side and add 5x to this side to have x's on one side. Always when we solve, we're trying to get something like that. X's on one side only, not both sides. So you have 9x equals negative 15. Divide both sides by 9, or multiply both sides by 1/9, as they say. We get negative 15 over 9. Solving a rational equation. This is called a rational equation. To do it, we need to clean up the denominators and get rid of the denominators. Imagine if I could get rid of 2x and 3x and 3. I'm not going to have fractions, which means I'm not going to have rational equations. So the idea is to look for the least common denominator between the denominators 2x, 3x, and 3. So 2x, 3x, and 3. That's the same problem. This is the whole work. All what you need to do is come up with the LCD, which is the LCD for these numbers or these denominators between 2x and 3x and 3 is 6x. You could see that 6x divides by 3 and gives you 2x. 6x divides by 3x and gives you 2. 6x divides by 2x and gives you 3. So it is the common multiple, and it's the smallest one. You don't want to go 60x, you don't want to go 12x, so we take the least one to reduce our variables and numbers. If you multiply left and right by the LCD on this right here, when I said 6x divides by 3 evenly and gives you what? See this right here? You could do that and you get 2x. So the right hand side we're looking at 6x that we came with, and we are looking at 3 at the bottom side, and that gives you 2x. And that's what we have right here. You do the same thing on the left, and you distribute right here, and you distribute right here, and now 6x with 2x is going to communicate and simplify. 6x with 3x is going to communicate because it's the least common multiple. So simplifying that, you get 2 right there. Simplifying that, you get 3. Now you just do algebra steps, multiply, and I get 21 here minus 10 equals 44x. 21 minus 10 is 11. Divide both sides by 44 and you get 1/4. Let's go for the next one. I have solving a rational equation. One more time. A rational equation that has fractions like this with variables involved. x2 and 2x, the common denominator is the LCD, which is called 2x. So to solve for this problem, we're gonna bring 2x. We're gonna think about the LCD, which is 2x, and start solving. Keep in mind that only one variable is excluded from a solution set, which is 0. We cannot have 0. 0 cannot be here, 0 cannot be here. We cannot divide by 0. A over 0 is undefined. So anytime that you get something that will force the denominator to be 0, you should reject from your solution set. Okay, so here we bring the 2x to both sides, as you could see, to cancel. And the 2x and 2x cancels. The 2x right here will get distributed, as it's mentioned. Between 2x and x, you get 2. Between 2x and 2, you get x. X times 3 is 3x with a minus. 4 minus 3x equals 7. Subtract 4 from both sides, subtract 4 from both sides, and I get minus 3x equals 3. Divide by negative 3, I get x equals negative 1, and that should be fine. Okay, it's not 0. It's not forcing the denominators to be 0, so we should be fine. Next, and that's just to confirm that the solution set is negative 1. Here's another example. The LCD between x and 10 and 4x will be what? Something that divides by 10, something that divides by x, and divides also by 4x at the same time without any remainder. And if you break it down, that 10 is 2 times 5. This is 2 times 5. That's what they have. And the 4x is 2 times 2 times x. And the x, is, of course, is an x. So I need a number that has 2 2's, has an x, has a 5, and that should be 20x. So I need a 2 times 2 times 5 times x. Because if you have that, which is 20x, you could see inside it there's a 5. So it's going to divide by 10 when you look at 2 and 5. It's going to divide by 4x because it has the 4 and it has the x, and so on. So we bring 20x to both sides, as you could see, to cancel the denominators, all of them. We do the distributive and we simplify. 20x divided by x is 20. 20x multiplied by 1/10. 20x over 10 is going to give you 2x. And of course, right here, when you see it next to it, 20 divided by 4 is 5. X cancels. 5 and 3 will give you 15. And add 15 to both sides. 35 divided by 2 divided by 2. 35 over 2. And 35 over 2 does not cause the denominator to be 0. So we are fine. The solution is 35 over 2. Here's 3 problems of rational equations with different approach, at least for the first one, and more practice. Let's take care of the first one. The denominator in the first one is x, or the denominators x and x minus 6 have nothing in common. Therefore, the LCD, you have to multiply them. Like, what's the common denominator between 2 and 3? They don't have anything in common, so you have to go up to 6. 2 times 3 is 6, and that would be the common denominator between 3 and 2. Same thing here, we multiply them. So instead of doing, as you can see, however, for this problem, we could just cross multiply. And that's why I said, like, the first one has a different approach. You cross multiply 5 times x minus 6 and 3 times x, as you could see right here. Then do the distributive. 5x and 3x, we like x's to be on one side. Subtract 5x, subtract 5x, and you get minus 2x equals negative 30, and we're done. So the answer is 30. And if you look at 30 here, if you look at 30 does not cause this denominator to be 0. That does not cause this denominator to be 0, so we are fine. 15 is the solution. The excluded values are 6 and 10 because I can't have 6 and I can't have, 6 and 0, and I can't have 0 right here. But none of my solution sets came up to be 6 or 0, so I'm fine. Part B. Looking at part B, we need a common denominator, so the common denominator will be between x minus 3 and x minus 3, which is the same thing, and 2. They don't have anything in common, so I need to multiply it, both sides. So it's 2 multiplied by x minus 3 combined, as you can see. And that's my LCD. Alright? Bring it to both sides. Do the math. Distribute, simplify, cancel. And you could slow me down here. It's kind of hard to read everything here and call it a lecture video. But you have all the steps. You could just verify it and move on. If you have any questions, you could leave them down below and I'll get back to you. You also could always pause the video so you could look at the notes by hitting the spacebar, and by hitting the spacebar again, that will make it play. So the spacebar acts like a remote control to play and pause. Okay, let's go for the next one. The solution set is 13/3, and the excluded value is 3 because we cannot have a 3, as you can see, but 13/3 is fine. Okay, next one. On the last one, x minus 2, x minus 2, and 2, we have x and x minus 2 and 2. So we multiply them together, and this is our LCD. And when you do it, you get x equals 4, and 4 doesn't have any problem here. So that is our solution set. Example number 7. X plus 2, x minus 1, x squared minus 1. This is interesting. This right here, if you factor it, we had it in a previous video, it's a difference between two squares, which factors to x minus 1 and x plus 1. So, as you can see right here, that is the last denominator. So, it's almost like you have 2 here and 3 here, and you have 6 here, and 6 is actually 2 times 3. So that's going to be the LCD, as you can see here, right? So you bring the x squared minus 1, which is actually, let me write it down, even though it's written right here, but it doesn't hurt. This right here is our LCD. So the LCD is going to end up x squared minus 1, which is actually x minus 1 times x plus 1. Let's make it times right here. So that is right here and right here. So if you bring it, that is my LCD. Bring it to both sides. That should be fine. And that's my LCD. That's my LCD. Okay? Which is the same thing as we agreed on x squared minus 1. Once you bring it, it's going to cancel this. Let's change the colors right here. It's going to cancel both, and you're going to end up with 2x. On this side, when you do the distributive, when you go in here, that x plus 1 cancels, and you'll see with x minus 1. When you go all the way here, the x minus 1 cancels, and you stay with x plus 1. Do the distributive, combine like terms, simplify, add 3 to both sides, or add x to end up with x. This time they had it on the right side, which is either way fine. X equals -3. If you go back right here, it doesn't cause any problem in the denominator. So the excluded values are -1 and 1, and we are fine. Next one. Here's some examples that we're going to solve. Now let's take a look at this one here. I have 2x plus 1 equals -9. So I'm going to subtract 1 from both sides. This cancels, and I get -10 and 2x. Divide now both sides by 2. Divide both sides by 2, and I get back x equals -5. -5, let's double check. You don't have to, but it's worth it if it's worth points. 2 times 5 is -10. -10 plus 1 is -9. Yes, it's 2. Let me gonna go a little bit fast. I don't wanna focus on my handwriting. It's my first time using this stylus and this tablet, but I want to make sure that I'm gonna get the right answers without mistakes. So I'll be looking at my notes to make it quick, and I'll be focused on, as I said, on finishing the problem, and last time not just my handwriting. So if I slow down, I'm gonna take more time, so let's not do that. Okay, right here, I think we could just start, instead of rewriting the problem to save you some time, use a distributive. So I have -2 times 3x, which is -6x, -2 times -1, which is +2. We'll bring x down, And now we have on the right side 14 minus x. And if you combine like terms, I'm gonna have to focus with you and use different colors right here. That's a minus 6x on the left and 1 positive x. That's gonna give you what? Negative 5. That's called combined like terms. Negative 5x plus 2 equals 14 minus x. Now after that, we could just do the following. We could have x's on one side. Usually the default is left side, doesn't make any difference. So we'll just do this. Add x, add x. I could do 2 steps in one, but I'll just wait for now. And we'll move on. Going back, so I have here minus 5x plus 1x, which is minus 4x. And 2 is going to go down. And I have 14 right here. And of course, this cancels. And that's just to clean it up and move on. Going back to the problem now, I have minus 4x plus 2 equals 14. I need to clean it up and have x on the left by itself. The concept is always having x on the side by itself. That's called solving. So let's get rid of 2. Subtract 2, subtract 2. I get minus 4x equals 12. Divide by negative 4. Divide by negative 4. And I get x equals negative 3. And negative 3 is our answer. I'm not going to take more out of your time to check it. It should be fine. I checked also myself the answers. As you can see, I did that on the side just to save you some time and avoid mistakes. I mean, like everybody does mistakes if you go fast and rush. Let's take another one. In this case right here, we're looking at the right hand side, rational equations. If you look at this 4 and if you look at this 6x, the LCD between 4 and 6x is 12x. 12x divided by 6x, which is 2. 12x divides by 4, and that is 3x. So if you notice right here, that's another way to see it. This is a 2 by 2, and this right here is a 2 by 3 by x. And I have to have 2 2's and 1 3 on x, and that's the 12. 12 is 2 times 3 times 1 more 2. Let's put it up front, times x. So in order to divide by 4, you have to have 2 2's. In order to divide by 6x, you have to have a 2 and a 3 and x. That's called the common denominator. So you have to have them all. So one way to do it, I could multiply both sides by the LCD, but what they did, or what I have in my notes, is we're going to multiply the right hand side by, or actually, let's see. There's different ways of doing it. I could multiply this by 12x and get rid of the denominators, but let's not do that. Let's do the following. I have 2 over 3x on the left, and I have 1 over 4 minus 1 over 6x on the right side to have a common denominator right here, which is agreed on to be 12x on the right side, right here. To get that, I need to multiply this by, let's see what's missing. We have 4 and we have 3x. Multiply this by 3x. Multiply 3x if you want to show the whole work by 3x. This here is 6x. To make it 12, I'm going to multiply by 2. I'm going to multiply by 2. And now I have 3x right here minus 2. So that's my right side, and the left side I did not touch it. Then we could go back and do the method that we saw in part A in one of the problems. Excuse me. And do the cross product. So by doing the cross product, I have 2 times 12x, which is 24x, right side 3x times 3x minus 2, 3x times 3x minus 2. I have now, let's see, 24x equals 9x to the second using distributive, minus 2 times 3x, which is minus 6x. Now, having everything on one side, I'm gonna do the following. I'm gonna subtract 9x to the second. I'm gonna add 6x to cancel this and cancel this. Of course, I have to do it on the left side. Minus 9x to the second and plus 6x to keep it balanced. And this is how we do math. We just have to keep it balanced. Left hand side, I have 24x plus 6x, which is 30x minus 9x to the second, and right hand side is just 0. So I have everything on the left. Now we could use our algebra techniques by factoring out from both sides minus 3x. Let me write it down here for you. 30x, I just want to copy it first so it could stay focused. 9x to the second equals 0. Take minus 3x out. From the first one, I have okay, I rearranged them, so let's write it down. I took the minus. I could do that, but I'm skipping steps, as you could see. Minus 10 plus 3x. You don't have to take the minus out. You could just like take 1x out first and move on. You know what? Let's just ignore that. And let's do it in a different way. Let's, let me do the following. I'm gonna approach it differently. I'm gonna save some steps and make it clear. Notice that 30x and 9x to the second, they both divide by 3. So I'm gonna multiply everything by 1/3. I want to reduce my numbers. Divide by 3. So the left hand side becomes 30x divided by 3, which is 10x. 9 divided by 3, which is 3x to the second, equals 0. Let's take x out this time. Instead of the way they did it with the 3x, let's just take x out. From 10, I have 10x, I have 10 only left. From this right here, I will have a 3 and x equals 0. Now this will give you two answers. Either this equals 0 or this equals 0. When you first solve for this one, you get x1 equals 0. And from this right here, setting it equal to 0, I am reducing the work because I'm running out of room. And you'll get 10 over 3. Alright? 10 over 3, 3 cancels, you get 10 minus 10, 0. Yes, just double check quick. Now if you go back to the problem to check your answers, I can't put here. I can't use this. Let me use a different color. I cannot use this right here in the denominators, this one, and in this denominator right here. I can't. So I have to reject this, and the answer should be only 10 over 3. That's the answer, all right? This is the answer. That should be rejected. So you got to be careful with these problems. Okay, that's like an extra space, but we are fine. I just finished it in the same slide. Here's another equation. Also rational. To do this, one way to do it is I'm gonna go back up here and multiply this by 2 and multiply this by 2. Why do I do this? Because if you notice, that becomes 4x, which is identical to this right here. And this right here, I could leave it or multiply by x and x, assuming that x is not 0. Okay, moving here, I'm forcing the fractions on the left to have the same denominator. That's one way to do it. So that's a 4x. That's our focus. Plus, and that was a 4x, so we'll keep it there. That's a 3. Don't forget how we have a minus here. You could put it on top. I prefer to have it on top. So it's a minus, minus 5 times 2, which is minus 10. And now I have minus 7 over 4. I did not touch it. I'll keep it. You know how to add fractions with the same denominator, so I'm going to just make it one denominator, one fraction bar. Minus 10 plus 3 is negative 7. And here, negative 7 over 4. You could flip them. You could multiply both sides by negative. Let's see what we could do. Okay, I could multiply by 4 and negative 7 both sides to clean it up. And if I do that, this cancels and the 4 cancels. You see, it's a reciprocal of minus 7 over 4 that I have on both sides. So this becomes 1 over x, and this becomes just 1. Flip it, and you get x equals 1. And 1 does not affect any of the answers or the denominators to make it 0. So we are fine. Next one. To do this problem, we're gonna use the concept that we talked about earlier, which is called cross product. Or you could find the LCD and multiply both sides. It's gonna be the same, but that will save you some time. So what we have here is 4 times. That's a 4 times 2x plus 1. Sorry about that. Let's erase that. Went too quick. Okay, that's one way. 4 times, and now 3 times. With the minus sign, of course. 3x plus 1. To finish the problem, we're going to use the distributive on both sides. So we have 8x plus 4, of course. And here, distribute again. It's a minus 9x minus 3. Now, we could have x's on one side because that's the way we like. And that's our aim, to have x's on one side only. As I always say, when you solve, you are going towards something like that. So that's going to cancel, of course. And I have 17x on the left. 9x plus 8x. Bring the 4 down. And I have the negative 3 that goes down. Next, we are going to do subtract 4 to leave x's alone, because 4 is in my way. And we have now 17x equals negative 7. Divide both sides by 17, and the answer is negative 7 over 17. And that should do it. We're almost done. Notice that negative 7 over 17 does not make the denominators either 1, 0. So we're fine. Okay, here's another one. Let's see if I have one more. No, that's an extra space. So this is our last one. Our last problem. So going to the right side, I have this much right here. And this much is actually x minus 2 times x plus 1, if you factor it, which is interesting to have right there. So that's my LCD. All right. So one way to do it is you multiply everything left and right by the LCD, which means you're going to cancel all of them. So you multiply left and right by x minus 2 times x plus 1 over 1. Right and left. When you multiply right and left, it's going to stay balanced. On the right side, that is obvious. It's going to cancel and it's going to give me 1. On the left side, when you take this all the way right here, distribute, this is gonna cancel. You see that? So we're gonna stay with x plus 1. So let's do that and save some time. So I have 2, that's this 2, and we have the x plus 1 that shows up. And on this fraction, the x plus 1 cancels, and you'll have x minus 2. So it's a 1 multiplied by x minus 2. Do the distributive. I have 2x plus 2. And here I have x minus 2 times 1, of course. It's not going to make any difference. Combine like terms, x and 2x will be 3x. 2 and minus 2 cancels. Divide both sides by 3, and x equals 1/3. That should do it, and we are done. Hopefully that was helpful, and I will see you in the next one. Thank you. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.